All right, good afternoon, everyone. Welcome to, I believe it's our third installment of the Cognitive X ASP.NET MVC webinar series. Today we're going to be looking at what's called inversion of control using a technology called StructureMap, as well as unit testing and how IOC can help make your unit tests that much easier to write. And so today, as I said, we're looking at MVC. My name is Adam Greene, for those of you who are new to this presentation series. I've been a computer programmer for over 15 years now, specializing in Microsoft Web Technologies. I've been doing MVC since it was beta pre-1.0, and I've been with Cognitive X now for a little over 2 years. So let's talk about what inversion of control is. Specifically, we're going to be looking at what's called dependency injection, which is a design pattern in which configuration is separated from use. Basically, that means that normally when you're running classes, the dependencies for all of your different classes and services, you normally end up hardwiring them into the constructors of your classes. With dependency injection, you actually separate the business logic of your classes from the underlying services like database and logging and all of that, and have an external system. In the case of today, we're going to be looking at StructureMap. Have an external system inject those dependencies into the class, so you don't have to worry about what your database system is or how you're doing logging or whatever. It is based around the use of interfaces and having your IOC container worry about the implementation of those interfaces. There's basically two types of dependency injection we'll be looking at today. The first one is constructor injection, which involves injecting parameters into your constructors. And then the second one is what we call property injection, which you usually only use when you don't have control over the actual instantiation of new objects. And we'll be looking at both of those today. So let's take a look at why you would want to use IOC in your MVC projects, especially. It's highly recommended when building software, especially with an MVC website, because of flexibility of configuration. With a IOC container like StructureMap, you have two ways that you can do configuration. One is with XML, and the other one is with what's called a fluent interface, or through writing code describing to StructureMap how you'd like to configure your system. One of the nice things about the fluent interfaces that we're looking at today is that in the area of flexibility of configuration, it actually allows you to write logic into your configuration that the configuration can change based on the system that it's running on, the available libraries, and available technologies. Like, there's a lot of really neat stuff you can do in the area of setting up and configuring your website based on all kinds of different criteria. Secondly, reusable configurations. With pretty well any IOC technology, they have the ability to create what they call registries, which is a block of code that describes a configuration of specific technologies. One of the biggest example we have here at Cognitive X in the way that we develop our software, all of our code related to our database access is done using what's called the repository pattern. And we most of the time use in Hibernate to implement that pattern. So we have a library that we include into our projects that contains a registry that manages all of the configuration and setup of the repositories based on in Hibernate. And StructureMap can automatically identify that that DLL is there, and it can load that registry and configure our database access. So by simply including a DLL into our project, we automatically get all of our database repositories set up for us. The next thing is managing of object lifetimes and life cycles. One of the nice things about an IOC container is it can actually manage how long objects exist within your system. With StructureMap that we're looking at today, we have 4 different lifetimes that are available to us out of the box. The first one is singleton, which means that for the life of the application, only one object will be instantiated and will be used every time it's requested. The next is what we call the HTTP context scope, or simply showing the lifetime of a web request. So from the point that a page is requested until it is returned to the web browser, objects created during that time that have a HTTP context scope will exist for then, but when it returns to the end user, then that object is disposed of. We also have ones that store the objects into the session, so the object will exist as long as the user is logged in and has an active session. There's also thread local, so that every thread within the system will have its own set of objects. And then finally, there's what we call transient, which means that every time you request an object from StructureMap, it will always return a new one. And then hiding of implementation details. Well, that's one of the big keys with object-oriented programming, is that the details of the implementation of a class are hidden most of the time from the end user of that class. The same is true with inversion of control. Because it is based on using interfaces and having concrete classes to implement those interfaces within the IOC container, it sort of gives another level of implementation hiding, which also makes it very easy to switch out technologies. Like, for example, I had a recent project where we started with Entity Framework because it was quick and easy to get off the ground with. But then as we went along, we realized that Entity Framework just wasn't going to cut it for the data manipulation and saving that we needed to do, so we switched over to Hibernate. Well, it's a fairly large application. It's got 20-some projects within the solution. But switching from Entity Framework to Hibernate was as simple as implementing the repository pattern with Hibernate and telling StructureMap to serve that up instead of the Entity Framework repositories. And immediately our application was now working off a different database technology. We didn't have to make any change to business logic anywhere else in the website. And because of this implementation hiding and the decoupling of classes through the use of interfaces, it makes testing your applications a whole lot easier. Especially when you don't have to worry about database access or logging systems or anything like that. And we'll see how that works near the end of this presentation as to why the use of IOC makes testing so much easier. When you should not use inversion of control, there are not very many reasons I can think of why you wouldn't want to. It makes configuration so much easier, testing so much easier. However, if you are in a scenario where speed is of the utmost importance, such as in a real-time system, IOC can add lag to your application. It varies depending on which IOC container you use, because there are some containers out there that are actually specifically tuned for speed rather than for flexibility and configuration. But you can assume on average that you're looking at about 10 times slower on looking up and instantiating services within your application when an IOC is involved. Also, some IOC containers do not work in the more limited class spaces of Silverlight and Windows Phone, or in places where reflection-related classes are unavailable, such as high security web context. So, in those cases, you really shouldn't be using IOC or can't use IOC. Like I said, today we're going to be looking at StructureMap for our demo in IOC today. It's the main one that we use here at Cognitive X. There are many other examples out there of IOC in the .NET world. Microsoft has their own called Unity. There's also AutoFac, HaveBox, Simple Injector. Style MVVM is more than just an IOC container, but it does within itself contain an IOC container. And there's like 20 other ones out there. If you do a web search for .NET IOC comparisons, you'll see all kinds of lists out there of the different IOC containers that are available. And AutoFac and HasBox, they're fairly quick, but not as, like I said, not as configurable as StructureMap. So let's actually jump in and take a look at how inversion of control actually works. With any new technology or language, you invariably see that people do the traditional say hello application. So that's what we're going to look at today to start with. It's just a basic hello world using inversion of control. So here's our first example. We have an interface called iSayHello that has a method that will say hello given somebody's name. And then we have a class here called consoleHello that implements the iSayHello interface and writes out the line to the console. This little bit here about I have been called X number of times, we'll get to in just a moment. So let's take a look at how you actually configure StructureMap to be able to serve up the iSayHello interface. In the most basic uses of StructureMap, you will be using what's called the object factory. It's a static class that manages the resolution of interfaces to concrete classes. And we need to configure it, telling it what interfaces we want it to resolve. So we say here that for every request for an iSayHello interface, actually I'm just going to remove singleton for a moment. So for every request for an iSayHello interface, use the consoleHello concrete class. So if we go down here, we're again using the object factory, but this time we're saying, give me an instance of the iSayHello interface. We're not worried about what actually implements it. We're just saying to StructureMap, please give me an iSayHello interface that I can then use. And which we do by saying running the hello.sayHello. And then back here in the main method, we call this submethod performHello 3 different times with 3 different names. So let's actually run it and see what happens. All right. So it ran and printed out 3 times, the 3 different names that we specified. But it says here I've been called 1 time, 1 time, 1 time. As I said, with transient life cycles, every time the get instance is called, it will give us a new object. So let's go back up here and put singleton back in here. And let's run the same, run it again. You'll have to excuse me, the DOS window keeps popping up on my other screen here. So this time when we run it, it doesn't say 1, 1, 1. It says 1, 2, 3 because, like I said, when you mark a class as a singleton, it only instantiates 1 copy of that object and uses it for every place and every time that it is requested. The other options that we have that I'm not going to get into right now because some of them I can't even use like right now because HTTP context scope, I'm not in a web application, so that's just going to throw an exception. There's also, see, you've got your hybrid HTTP or thread local scoped. There's also session and several other ones, and you can even write your own. For a WCF project I was doing, I actually wrote a call context-based life cycle. So that's your most basic example of using inversion of control. But still, the problem here is that we're setting up the object factory here, and then we're just using get instance to pull out an interface. We want to actually take it to the next level, which is when we is to actually use Constructor Injection now. So we still have our I say hello interface, but now we're going to introduce the iWriter interface that will write out a message to whatever medium it's going to work with. We don't, at this point, we don't care where it's being written. We just want it to be written. So we have I created an implementation of the iWriter interface with the console right here, which then again will just print out the message to the console. And then we've modified our console hello class to simply be hello, because it's no longer dealing with the console, it's dealing with an iWriter interface. So it doesn't care where it's being written. It just this class on the constructor, one of the parameters is the iWriter. When StructureMap goes to create an instance of the hello class, it will look at the constructor and say, okay, you are asking for an iWriter because it's one of the parameters to the constructor. And StructureMap will look at it itself and say, okay, I know how to implement an iWriter, so here you go. So when this class is going to be instantiated, it's going to be given a copy of an iWriter, which it's then going to store in a private variable. And when I call say hello, it is going to use that writer to write out the message. And down here in our main method, one of the changes we make is we now are adding this line here to set up our iWriter. And we didn't have to make any changes to the next line because StructureMap is going to inspect the class for us and automatically recognize the dependencies that the hello class has. The difference you'll also notice here is that I've actually put in a lambda expression indicating to StructureMap how to create a copy of the object of iWriter. If I didn't put that in there and I just wrote that, then I basically have created the equivalent of a singleton because that class will be instantiated and then handed off to StructureMap, so there only will ever be one copy of that object in the system. That's why we have to write it as a lambda like that, so that it's now a function that gets called every time the iWriter is requested. So down here in perform hello, again, there was no need for any changes because StructureMap is going to handle all of the setup of the I say hello interface for us. So let's run this one. And here's our output again. The numbers you see here at the beginning, they're all ones, and so it also says here it's only been called one time because both of these are marked as transient. But that first number one comes from inside of our console writer here, where I'm outputting the count of times the console writer has been called. So that I just want to show you again some examples of life cycle and how they all interact within StructureMap. So I'm going to make my console writer a singleton, but I'm going to leave my I say hello implementation as transient. And when I run it this time, what you're going to notice is that the first numbers now indicate that our writer is being reused because the count keeps going up. However, the count on our I say hello interface is not going up because it is still marked as being transient. There is no singleton or any other life cycle that's been specified. And if you don't specify a life cycle, it becomes transient. Now here's something to watch out for when you're dealing with IOC, and it can cause problems if you're not aware of it. If I marked my I say hello implementation as singleton, but I leave the console writer as transient, which should effectively mean that every time we call our iWriter, it should give us a new copy, and the I say hello will only have a single copy, but that's not the case. As you'll see, it counts up 1, 2, 3, and 1, 2, 3. So the iWriter implementation is hanging around. That's because the implementation of the I say hello, which is marked as a singleton, takes a writer and it's holding on to that writer, even though the writer is not marked as being a singleton. So just watch out for that when you're using IOC, that you may have a singleton that's holding on to a reference to a transient object. And we had a case where we were getting very strange results out of database queries until we realized that what was supposed to be a transient class that was dealing with transactions was actually becoming a singleton because it was being held by another singleton. And we had to rewrite part of our system in order to overcome that. All right, so that is constructor injection. Like I said, we simply provided a parameter to the constructor of the class indicating what other services this class required, and StructureMap took care of filling those out for us. So let's take a look at property injection, which is another way that injection happens. We still have all of the same classes, except you'll notice that on the hello class here, I no longer have a constructor. Instead, I simply have a property the type iWriter. So I'm just going to comment this line up for a moment. We'll talk about this line in a second. So if I run this now, what we're going to get is actually a crash. And the reason that that happened is we have to instruct StructureMap in some way as to which properties on the objects actually need to be filled out by StructureMap. In cases where you actually have access to the class and you can actually alter the class, all you have to do for it to work is to mark that property with the attribute setter property. And when we run it, StructureMap will take care of filling it out. And there we go. It didn't crash that time. However, there are times when you want to fill out the properties and objects that you do not have control over and you can't alter the original class. In that case, you can use, within the configuration of your object factory, you can say that for all properties of a given type, I want you to fill them out when you do property injection. And here, now that we removed the attribute up here, and we've added this line here, so now when we run it, again, it works as expected. StructureMap recognized that property needed to be injected and did so. The other change that you'll see here is instead of asking StructureMap to provide me with an instance of an interface, I simply instantiated concrete object. Then I requested that StructureMap build up that object by filling out any properties with the services that are registered with StructureMap. And then we ran it. So the next step we're going to look at here is looking at moving our configuration out into a registry. So here, if you look at the configuration of the object factory now, instead of having each of the interfaces and what classes implement them, the for and the use convention, we simply have a scan command, and we're telling StructureMap to look in the calling assembly, which in this case is the say hello registry executable, and then we're saying look for registries. Now I've written a registry here called the hello registry, and I have in here the configuration that you've seen in all the previous examples. And so when I run this, it is going to do the same setup that it's been doing all along, and it's going to run the same way it's been running all along. But now that we've moved it out into that registry, we can, like I said, you can create multiple class libraries, put registries into those libraries, and then tell StructureMap, inspect the DLLs in this directory, inspect the ones that are loaded, inspect, like there's all kinds of different commands that you can send to StructureMap to explain to it how to find registries. But it makes it a lot easier to manage applications, and as you develop and enhance core libraries of your company, and with those registries being in those DLLs, it's just as easy as including that DLL to have all of the services registered in it into StructureMap simply by looking up registries. All right, so that's just a quick introduction as to how IOC works. Next, what we're going to do is actually take a look at how it works within MVC. And there's actually a really nice convenience library that you can add through the NuGet package manager that will take care of setting up StructureMap within MVC for you very, very easily. Simply by including the StructureMap.mvc4 NuGet package, it will automatically add in StructureMap, it will configure it, and inject it into MVC, so you don't have to worry about how are you going to get this into your MVC application. Just include that package, and it'll take care of everything you need to do for setup. And it just quickly, so that you know, it adds the dependency resolution folder, and it adds the IOC class, which does what we just saw about, you know, scan the calling assembly, look for registries, and I have created a registry here that registers all of the services that are going to be needed for the presentation today. I have an HTTP context scoped entity data model context. I then have a people repository. I also have an iMessage interface that we're going to be using to show off property injection. I have what's called the View Page Activator, which we'll look at in a few minutes as to what that's for. Here's another convention with StructureMap that you may have to use occasionally. When StructureMap is inspecting the constructors on a class, what it'll do is it'll actually go look for the most complicated constructor, look for the constructor with the most parameters, and then try to fulfill the requirements of all of those parameters. Well, in the case of an entity data model context, one of the parameters that it wants is the connection. One of the options is the connection string to connect to the database. Well, by default, that's already included in there, and you only have to provide it a different one if you're actually changing where or how it's connecting to the database. So we don't want StructureMap to pick that constructor. So with this convention, we can tell the constructor, tell StructureMap the constructor we want is the one that has no parameters. And then again, we have our set all properties for the iMessage interface that we have up here. So let's go take a look at our controllers. And specifically, we want to look at the person controller, because that's going to be sort of the heart of what we're going to be looking at today. And for this presentation, I created a people repository using the repository pattern. And by simply adding a reference in the parameters of our controller to that people repository, StructureMap is going to automatically inject that repository into a controller every time these controllers are instantiated. The reason it can do that is that as part of the setup of StructureMap through that package we included, is it adds the StructureMap dependency resolver class to the startup of MVC through in the app start folder. There's a StructureMap MVC class, and it actually registers the dependency resolver with MVC and also sets it in the global configuration for Web API. So you don't have to worry anymore about how you're going to actually tell StructureMap what to inject, because that's all set up for you. You just simply have to include the services that you want from StructureMap in your constructor parameters. So then we have your typical CRUD operations going on here, where we have an action for showing you the details of a particular person object. We have the index that gives you a list of all of the people. You have your ability to create a new person object in the system. And again, you'll see that we're also using AutoMapper. If you missed the last presentation I did on AutoMapper and why you should be using AutoMapper rather than directly using your database objects, go back and watch it. It's worth watching. It will save you from getting into trouble down the road with people trying to hack your website. Excuse me. So we have your basic CRUD operations going on here. Now let's take a look at how we actually implemented that repository. So in our interfaces, we have the iRepository interface, and we actually did it up with using generics. The reason I'm showing this to you is that it could be of benefit to you in any of the projects that you're doing as well. So then we have, within there we have the get by ID, the create, the delete. We have a get all, which takes an expression in order to narrow down the list of objects that you want to get. There's also the get all, which simply returns all of the person objects in the system. There's also a get for getting a single user back. Then there's a save and update. And then we created an iPeople repository simply by filling out the generic parameters of the iRepository with person, and the int in this case indicates the type of the identity key. And then we have a concrete implementation here called People Repository that takes an MVC IOC entities, it's an EDM context, and that's going to be supplied to it by StructureMap. And then this People repository in turn will then be provided to our person controller by StructureMap. So as you can see, we've got multiple levels of dependencies going on here, and StructureMap can have all kinds of levels of dependencies. I think the deepest level we've done in any project we've had here is actually 5 levels of dependency resolution. And then you can see here we've got all of the necessary code there to load, create, save, and delete the objects. So let's actually run this and make sure that everything's working as expected. All right, so let's go take a look at our person section of the website. So I've already got 2 people in the system, and as you can see, I can click them, I can edit them, I can save them. You know, your typical CRUD operations, they all work. But what I want to show you next is this line right here. Message. This is a message. Because I want to show you how dependency injection for properties can work within MVC. So let's stop our, okay, there we go. So if we go and we take a look at our views, that was the person index view. And I've added in here at the very top this functions block. And I've put in a property that's of type iMessage, and I've marked it as being a setter property, so that StructureMap, when it sees that on this view, will inject the iMessage interface implementation. And then I'm using that property here to output the message. The question is, how did that get in there? How did StructureMap know to inject that? Well, that comes from, go back up here to our registry, I've implemented the MVC Page Activator. What happens when MVC first is starting up and you specify that there's a dependency resolver, MVC starts going through to the dependency resolver and asking if it has any implementations of certain interfaces. And I'm just going to take a quick detour and just talk about some of those interfaces that MVC asks the dependency container if it supports. At the most basic level, you don't have to implement any of these interfaces. If you don't implement any of these interfaces, then MVC, every time it's looking for a controller, it will ask the dependency resolver, do you know about this controller, or do you know about this view? But then you can also implement these interfaces to either get more control or more precise control over parts of how MVC actually instantiates and uses objects. And the first one we have here is the iController factory that is responsible for resolving the name of a controller, in our case either home or person. It's responsible for resolving that name to an actual concrete class, and then instantiating an object of that class and returning it to MVC. There is a default controller factory within MVC when it comes out of the box. Like I said, you don't have to implement that interface. Next, we have the iController Activator. The default controller factory, once it has instantiated a copy of the controller, it will then check to see if it has an iController Activator. And if it does, it will ask the activator to, quote unquote, activate the controller, which is a place that then gives you the opportunity to do property injection on the controllers. And then, like I said, if you don't do either of those interfaces, then MVC will directly ask the dependency resolver, do you know how to implement this type, for example, person controller or home controller? Next, we have the iTemp data provider. For those of you who may or may not know, there is what's called temp data in MVC, and it's basically a short-lived session. You can put stuff into the temp data, and it will only exist as long as the next request to the website. So you can actually stick data into the temp data and tell the browser to redirect to a new page, and that data will be available to that new page, but then after that it's gone. It's disposed of after that new page is rendered. Then we have what's called the iAsync action invoker and the iAction invoker. The only difference is, obviously, is one of them deals with async methods and the other one deals with synchronous methods. Once a controller is instantiated either by the default controller factory or by your own implementation of the controller factory, the next thing it's going to do is look for the action on that controller. And that's where the action invokers come in. They are responsible for finding the method on the controller that needs to be called and then setting it up for us for the call. So if you need to override the default way that MVC does that, you can implement those interfaces. iFilter provider allows you to register filter providers with your IOC container and then provide those to MVC. Excuse me. And then there's also view engines. And by default, we have your classic ASPX and Razor view engines. But you can also add other view engines like Spark or Enamel or several others. And you can just simply register those view engines with the IOC container, in this case StructureMap, and then they'll be automatically picked up by MVC because it'll ask the dependency container, do you have any implementations of iView engine? There's also the View Page Activator, which is what we're going to look at in just a moment. That is responsible for once the action has been, controller has been found, the action has been resolved and called, the next thing it does is render the view. And it's up to the View Page Activator to find, load, and set up the view to be rendered. So we're actually going to insert our own View Page Activator so that we can actually do property injection on our views. And as I said, if you don't provide any special function processing like the iView Page Activator, then MVC will directly ask the IOC container, do you know how to implement this view? Then we have the metadata providers, the validator providers, the binder providers, and the value provider factory, which is kind of a bit more of an advanced topic that we just don't have time to get into today. But just know that if you know what those are, you can register those with an IOC container, and MVC will be able to pick them up. So let's go back here. As we said, we were going to talk about the iView Page Activator. So we created our own implementation of it, which is right here. And what we've done here is the MVC system is going to ask us for the type of a given view. And the names of the views for Razor are like super long because they take into account the path and everything to where the page is actually found. And so it's a really long name. But anyways, the View Page Activator will be handed that type, and then we can actually do a get instance of that type, and it'll actually return the view back to MVC, having done property injection on it because we've set it up correctly to do that. One of the things to note here is that in the constructor for the StructureMap View Activator, I have indicated that it's dependent upon an iContainer. iContainer is the interface that StructureMap provides to itself, so that you can call the get instance or get all instance against StructureMap from within services that StructureMap is providing. So it basically introduces a dependency on StructureMap for this class, but that's okay in this case because this class is more of a factory. These are more of the factory design pattern. So in those cases, it's okay to introduce this dependency on StructureMap. Otherwise, there's just no way for this class to work. But avoid as much as possible actually using a reference to iContainer unless it is inside of a class that is a factory. So, like I said, when MVC goes to render the view, it's going to come to the Page Activator. It's going to then ask that we provide it with a concrete implementation of the given type, and StructureMap is going to take care of that. It will property inject our view so that, like I said, this right here will be provided to us by StructureMap. All right, so we've gone through all of this of introducing the extra layer of complexity of having an inversion control or dependency injection in our website. You know, it's giving us some benefit. But one of the big keys that IOC really helps you be able to implement is testing. And we're going to take a look at today a bit at unit tests, especially how IOC makes them easier. When you do a file new application and you pick an MVC4 website, one of the options you have on the wizard that pops up is if you want to create a unit test project. And for today's example, I did say yes to that. So we ended up with a test project. And out of the box, you get the home controller test, which contains, I think, something, well, it used to contain like 20-some tests, but they've simplified it now. Actually, oh, sorry, they used to have the account controller test in there, and there was like 20-some tests in there, but they've taken it out in the latest version. So I wrote the person controller tests, which are going to test to make sure that my controller works the way that I expect. For example, here, when I hit the index page, I want to make sure that it is providing me with a list of all of the person objects that are in my system. So the first thing I did was I created a list of dummy persons to put into our system through this method called setUpPeopleList. And as you can see here, I create 3 different person objects, 1, 2, and 3. Each one has a different birth date and a different name. And then I put them all into a list and then I return it. The next thing I do is I set up a fake repository. And we're using a technology to do that called MOQ or mock because it deals with mock objects. So if you go into the NuGet Package Manager, you'll see here MOQ, the simplest mocking library for .NET 3.5, 4, and Silverlight. And inside of the setup repository method is where you'll actually see us using MOQ. And it's this line right here. Now this method is actually fairly complex that I've done here. It's using generics and all kinds of other tricks. The reason I put this in here is we're going to be making this source code available to you when this presentation is done. And this setup repository method, I use this all over my tests for our projects here, because it allows us to very easily mock up a repository for any type, for any type of data object. As you can see here, I simply say that it's going to be returning objects of the type person, and this is the interface of the repository that it should be implementing. So in here, we say mock our repository type, which in this case, it's resolving to iPeople repository. At that point, we now have a fully implemented repository. The only problem with the implementation of this repository is that any of the methods that have a void return type, they do nothing. Any methods that or properties that have a return type, it returns the default. So if it's a complex class, you can get null. If it's a string, it's going to be empty. If it's an integer, it's going to be 0. Like there's no usable information that's going to be returned. The nice thing about that, though, is that if you only need to mock up a single method on a class that contains like 20 other methods, you don't have to worry about implementing every one of those methods. You just have to worry about implementing the methods that you need in order to be able to run your test. But because this is a convenience method, I am actually going to implement every one of the methods on this interface. So we have it set up here for the getAll method. And when we do a getAll, we simply want to return all of the models. Next up, though, we have the getAll that takes an expression, a lambda expression, to provide the criteria, the where part of our lookup. And it uses a special type here in setting up this method call, and it is the it.isAny. If I was to write, say for example, I'm just going to jump down here. I'm going to stick something in here. I want to show you something. Using the getById method, if I was to write this, and if I took this method out, then the only call that is going to succeed the way that I expect it to the getById, is if I request ID number 3. Whatever you write in the setup is exactly what mock is going to expect to receive in order to return the value that you specify. So by using the itisAny option, as you see here for the with the int32, then this setup will succeed for any integer. But what that allows us to do in both the case with here the expression and the integer is it allows us in the returns method to actually specify, okay, this is one of the parameters that return is going to receive so that it can work on it. So what happens here is I take this expression, I have to compile it because we're working against a list, and a list doesn't work on expressions, it works as you see on func. So by compiling it, it will produce an actual function that can then be used here in this setup. And in the case of getAll, I return a list. In the case of get, which is a single object, I do a first or a default. And then finally, the getById is it's basically the same setup. We're doing a where and then returning. And so in this method, I've set up everything so that my mock repository can work against a list of objects that I've given it. That way we start from a clearly defined data set so that we can actually run tests to see how that data set has been affected without actually ever having to go to the database. We don't have to blank out our database, write a bunch of records to the database that we know are correct. We don't have to worry about accidentally overriding the production database because we forgot to change our data connection string. In fact, there's no database involved. It's all, we've faked all of the database interaction so that within our tests, we can actually test only the controller actions and none of the services that this controller depends on. So in our list, test list people, our homepage is supposed to give us a list of all of the people that are in the system. So we set up our controller here. One thing to notice is that we're returning a type here. It's not a iPeople repository. It's a mock of iPeople repository. So that's why you see a .object. That's how you get the mock to give up that implementation of that interface. So then we hand that off to our person controller. Then we call our index action. And then we actually can inspect the model that's part of the rendering of our view to make sure that we actually got the complete list of the people that we put into our mock data. And then finally, we can also ask the repository to verify that certain methods on it were called. You may have a case where the return type is true or false on the condition of your test, but you may end up with a false true or false positive if certain methods on your repository, for example, weren't called. So this way, it allows you to verify that the expected methods were called with the expected parameters. And we see that especially down here in the test create person. Again, we're setting up our controller. This time, we're handing off a person view model to the create, and then we're verifying that the create method was called, which creates an empty object. Then we used AutoMapper to fill out the properties on that object, and then we do a verify to make sure that save was called. And here we're using it as the convention it is, which actually allows you to specify a test to make sure that this method was called with the correct parameters that we were expecting to be called with. And here I just do a test to make sure the name equals test because I provided the name here as test. I'm verifying that I actually got an object with the name test. And then we do the same thing here with delete, except now we're not doing any verification on the repository. We're simply seeing if our list of people object has been decreased by 1. We started with 3. We want to make sure there's 2. Then we have for the update person, we are actually verifying that a object is loaded. And then we're verifying that update was called and that we've actually changed the name of our object to being new. So here it is as a parameter to the action, and here it is verifying that it was actually an update was called against that object and the name actually changed. And then we have a test on the actual displaying of the edit page. So like I said here, we are not having to access the database. We're not having to worry about the database. We're actually able to validate that methods are called on interfaces in the way that we expect them to be called so that we can actually run tests and be fairly certain that the results we're getting are accurate. So let's actually run this test. These tests have been implemented using the standard Visual Studio unit testing. So I can just go up under Test menu and tell it to run all tests. And looks like we don't have our Test Explorer window open, so I'll open that. And as we can see here, we got all green check marks. Everything passed as we expected it to. All right, so that's our quick introduction to inversion of control with StructureMap and how you use it in MVC and how it can help you in writing your tests. If there's any questions, please feel free to type them off here in the chat window, and I will do my best to be able to answer them. But just want to let you know that Cognitive X is available to help you with your next project. If you want if you need any help in any way with any projects that you're working on, we'll be more than happy to help you with architecture or code reviews, to training to implementation. Our contact information is here. You can call us at 1-800-670-COG-X or at info@cognitivex.com, or check out our website. And we are still looking for people in this area. We're located here in Moncton, New Brunswick, Canada. Anyone in this area who is looking for a job, we're more than happy to receive your resume and talk about any potentials or possibilities here at the company. We will not be doing a presentation in August, as I would like to take a break. But we'll be back in September, and I think we're going to be looking at aspect-oriented programming, and we may actually have some working on a possibility of surprise for that one. Stay tuned for that. We'll put out an alert to let you know when the video from this presentation is up, because thankfully this week, for those of you who watched previous webinars, I actually remembered to push the record button this time. So we should have this up early next week. Like I said, we will be making all of the source code and the PowerPoint slide deck available as well. So if there's no questions, then I will say that we're done for the day. And thank you very much for tuning in, and hope to see you again in September with our next webinar. And have yourself all a great day.